Hello again, 5th graders. We are on lesson 5 in unit 1, adding and subtracting fractions. And today we're going to look at fractions that are greater than 1. Because we can have fractional amounts that are greater than 1. So we're going to start off by just reviewing a fractional amount that is not greater than 1. Because if I had 1, that means this entire circle would be shaded. But the entire circle is not shaded, right? So in order to write a fraction for this picture, I would count how many pieces are shaded, 1, 2, 3, 4, 5, and the number of pieces that I'm using or that I'm counting is my numerator, so this would be 5, and the total number of pieces is my denominator, so there's 5, 6, 7, 8 pieces here. So hopefully we can all agree that this picture right here represents 5/8. Now, when you look at letter B, remember your numerator is the number of pieces that are shaded, right? And you can see in this one, this is the same one as letter A. It's the same shape, but a different amount is shaded. That 1, 2, 3, 4, 5, 6, 7, 8 pieces in this are shaded. And then I have 9, 10, 11, 12, 13. So 13 total pieces are shaded. That would be my numerator, the number of pieces that I'm counting. My denominator is how many pieces the whole is broken up into. So I have 2 circles here. One of those represents one whole circle. So the denominator is how many pieces one whole circle is broken up into. And each circle is broken up into 1, 2, 3, 4, 5, 6, 7, 8 pieces. So 13/8 would be a way to represent this. And 13/8 is an example of a fraction that is greater than 1. We can see that. There are 2 circles here, right? We have one full circle shaded, and then we have part of another one. And when you have fractions greater than 1, and we write them as a fraction with a numerator and a denominator, you'll notice that your numerator is greater than your denominator because 8/8 would be one full. So if I have a numerator that's more than my denominator, that means that I have more than one full circle or square or whatever shape you're looking at shaded. Now, another way I could write this, instead of writing it as an improper fraction, you can also write fractions greater than 1 as mixed numbers. So that means it's a mix of whole number and fraction. So if I wanted to, I could look at this and say, okay, well, I do have one full circle shaded, right? So that's my whole number. The whole number is how many whole amounts you have. And here I have one full circle shaded. I also have part of another one. And how much of this other one do I have? 1, 2, 3, 4, 5 out of 8 total pieces. So 13/8 is equivalent to 1 5/8 because I wrote each of those for the same exact picture. Both of those represent this one picture. So fractions that are greater than 1 can be written as improper fractions or as mixed numbers. And our goal today is actually to be able to go back and forth between the 2 of those because that's going to help us when we're solving problems using addition, subtraction, multiplication, division. So that's our goal today. I want you to be able to go back and forth. And again, we've done that in class, so this is kind of a little snapshot of what we concluded after all of our building and visual models. All right, look at letter C. So improper fraction, let's write an improper fraction for this first. So if we're trying to write the improper fraction for it, and I know it's going to be improper because I have more than one full shape shaded here. So to get my numerator, I count how many shaded pieces there are. 1, 2, 3, 4, 5, 6, 7. And to get my denominator, I look at how much each whole is broken up into. So this is one full shape, right? One of these shapes is broken up into 1, 2, 3, 4, 5, 6 pieces. So this entire picture can be represented as 7/6 because I have 7 pieces and each whole is broken up into 6. I could also say, mixed number, that I have one full rectangle and I have 1/6 of another. So 7/6 and 1 1/6 are equivalent. Last one, maybe you want to try this one on your own. If not, it's okay, but you can always press pause and give it a chance. So here, okay, as an improper fraction, I see that I have 1, 2, 3, 4, 5, 6, 7, 8 pieces shaded. That's my numerator, the number of pieces shaded. The denominator is not how many total pieces I have here. The denominator is how many pieces each whole is broken up into. There are 3 full rectangles here. One rectangle is broken up into 3 pieces. That means 8/3 would represent this picture. As far as a mixed number goes, in this one, I have 2 whole rectangles shaded. So that's my whole number that I have. I have 2 full rectangles shaded, and then I have 2/3 of another because 2 out of the 3 pieces are shaded in that last one. Okay, so the first thing we're going to look at is how do you change a mixed number into an improper fraction, because that is definitely a skill you're going to need to use in this unit. And I'll show you a visual model for why it works, and then we'll go to the standard way to do it because we did get there in class, but normally we'd be building these things over a long period of time, which we did. So this is your quick little review. Okay, so in order to change a mixed number to a fraction, if you just printed out the notes and you're looking at them, I do give you the general way, and if you looked this up, this is like the standard way to do it. This is probably what someone would tell you. Oh, well, you just multiply the denominator by the whole number, add the product to the numerator to create your new numerator, and the denominator stays the same. And maybe if somebody said that to you, you'd be like, what are you talking about? You might not feel that way now because we did do this in class already, but some of you might be thinking to yourself, we did this a long time ago in class, Mrs. Tremblay. Please review. And that's what I'm here for. So 2 3/4, our goal is to write this as a fraction. I know it's going to be an improper fraction because I can see that I have more than one here. And when you have more than one whole shape shaded, you're going to have an improper fraction. So if you look at this 2 3/4, when I say that I have 2, that means I would have like 2 full circles or 2 full squares, 2 full shapes shaded. Do you see how we're dealing with fourths here? If you have 2 full shapes shaded and each whole is divided up into fourths, this 2 would actually mean that I have 4/4 and I have another 4/4. So 4/4 plus 4/4, that would mean 4 out of 4 are shaded in one shape, 4 out of 4 are shaded in another shape, and then this 3/4 means that I have one more piece here, or one more hole, but not all the pieces are shaded. Only 3 of them are. Excuse me. So 2 3/4 is the same as having 4/4 twice, plus that extra 3/4 of the other one that's not quite shaded all the way. And we had talked about when you're adding fractions here, if I have 4/4 and another 4/4 and then 3/4, I have 4 and another 4 makes 8 and another 3 makes 11. So I would have 11/4. So that's one way to go from 2 3/4 to 11/4. I look at my whole number here and I can change that into what does this whole mean as a fraction? So basically, if this is 2, that would mean I'm going to have this denominator twice plus another 3. So when someone tells you at home, oh, all you have to do is multiply your denominator by the whole number, 4 times 2 is 8, and then add your numerator, 8 plus 3 is 11, and keep your denominator the same, that's why this works. Because if you have 2 as your whole number, that means that you have 4/4 twice. So I end up doing 4 times 2 because I have 4/4 twice. And then we add in those extra pieces. So the simplest way to figure this out, once you can kind of visualize it and you have the visual model down, you can say, okay, well, if I have 3 2/5 and I want to write this as a fraction, it's going to be improper because I see I have more than one. I have 1 or more. Okay, so 3 2/5 would mean for 3, this 3 whole number means I have 5/5, 5/5, 5/5. How many times do I have that 5? 3. So to get my numerator, I can say, well, I have 5 times 3, 5/5, 5/5, 5/5, plus that extra 2 and the other whole that's not shaded all the way. So that means the number of pieces that I would have shaded would be 5 times 3 is 15, and 15 plus 2 is 17. And whatever number you have in your denominator spot, that tells you how many pieces the whole amount's cut up into. We're not changing that at all. That stays the same. So that's kind of a shortcut from getting from here to here. You could list it out as 5/5 plus 5/5 plus 5/5 plus 2/5, but you're still going to get 5, 10, 15, 16, 17. All right, next one, 2 3/8. I want to change that into an improper fraction. So if I have 2 as my whole number, that would mean I'd have 8/8 twice. That means I would have 8 twice. So I take my denominator times my whole number, plus I still have these 3 pieces out of the 8. So 8 times 2 is 16. 16 plus 3 is 19. And the number of pieces that each whole is cut up into did not change. It would be 19/8. Letter G, 1 7/10. Maybe you want to pause and try this one yourself. I would take 10 times 1, because I'd have 10 tenths here, and add those 7 extra pieces. And 10 times 1 is 10, plus 7 is 17. My denominator stays the same, so 17 tenths is equivalent to 1 7/10. Couple more, and again, you can try it on your own. 9 times 2, because I would have 9/9 and another 9/9 if I have 2, plus those extra 5 pieces. So if you take 18 plus 5, you would get 23. And our denominator, the number of pieces the whole's cut up into, doesn't change. It would be 9. Next, 1 1/25. This one means I'd have 25 over 25, right? One whole would mean all 25 pieces were shaded. So I'd have 25 one time, 25 times 1, plus I'd have this extra 1 in the other shape that wasn't shaded all the way. So that would mean that 25 times 1 is 25, plus 1 is 26 pieces would be shaded, and each whole amount is still cut up into 25. That does not change. The last one of these, I have 4 1/4. This 4 means that I would have 4/4 and another 4/4 and another 4/4 and another 4/4. An easier way to do that is just to say, well, I'd have 4 times. 4 times 4 is 16. Plus that extra 1 and the other that's not shaded all the way would make 17. And it's still all cut up into 4 pieces. So that's how you go from a mixed number into a fraction. I do want you to be able to go from an improper fraction to a mixed number as well, because when you give your final answers to things, that's going to be your simplest form. So, changing an improper fraction into a mixed number, the standard way that we ended up coming up to and concluding after all of our work in class was you just divide the numerator by the denominator to get the whole number. Then the remainder is your new numerator, and your denominator always stays the same. The number of pieces that the whole amount's cut up into is never going to change. And I can demonstrate that with this first example. I have 13/4 here. And I just said divide the 13 by the 4. You could look at this as, okay, I have 13/4, right? So we're dealing with fourths. So if you have 4/4, that would make one whole circle, right? 4/4 would make one whole. And if I have another 4/4, that would make 2 wholes. So far I'd have 8. I need to get to 13, so I have more. If I add another 4/4, okay, now I have 8 plus another 4, I have 12. 12/4, right? And, to get from 12 to 13, I can't do another full one, but 12 to 13 would be one more 4th. So we can see here that I have 1, 2, 3 full shapes that I could shade with 1/4 left over. That's kind of how we're arriving at these. And the way we came up with the shortcut is, okay, well, just see how many 4s will go into the 13. So 13 divided by 4, and 4 times 3 is 12. That tells me how many full 4/4 I can use. And then we have the leftovers, right? 13 minus 12 is 1. That's how many leftover pieces I'd have. So the remainder is my new numerator, and what it's cut up into, the piece sizes, that stays the same, 3 1/4. So you can use division to rewrite an improper fraction as a mixed number. So for letter K, and again, you can be trying these on your own if you'd like. It would be a great way to practice to make sure you understand this concept. I have 10 sevens. So I'm going to ask myself, how many full sevens will go into 10? And the answer is 1. How many would be left over? Well, 10 minus 7 is 3. And my denominator stays the same. So 1 and 3 sevens is equivalent to 10 sevens. And you can even check using what we just learned to make sure that it's right. 7 times 1 is 7, plus 3 is 10. And my denominator stays the same. So it works. Letter L, 12 fifths. So again, I can go ahead and say, okay, well, how many times does 5 go into 12? How many full times? How many 5 fifths can I make? Well, 5 times 2 is 10. So that's the number of 5 fifths I could make. I can make 2 5 fifths, right? Now, I still have 2 extra left over. So that means that 2 fifths of one more whole would be shaded. So 2 and 2 fifths is equivalent to 12 fifths. Letter M, 8 thirds. How many 3 thirds can I make with 8? Well, 8 divided by 3, 3, 6, 9 would be too many. So 3 times 2 is 6. That means I can fit 2 full groups of 3 into the 8. And there are, 8 minus 6 is 2, 2 left over. That's how many pieces of the other shape that's divided up into thirds I would have. Letter N, 15 fourths. So 15 divided by 4. I can fit 4, 8, 12. I can fit 3 groups of 4 into 15. So that would be my whole number. And when I look at how many I have left over, I have 3 left over. That means 3 fourths of another whole would be shaded. Letter O, 39 sixths. All right, so 39 divided by 6. 6 times 6 is 36. So I can fit 6 whole amounts. 6 will go into 39 6 full times. And here there are 3 left over out of 6. So maybe some of you are looking at that 3 6 and thinking, well, wait a minute, that's the same as a half. Yeah, 6 and 3 6 or 6 and 1/2. Either of those would be fine. 6 1/2 would be the best of the two because that is in simplest form. But you'll talk a lot more about that in 6th grade. All right, last one of these, we're almost there. 51 tenths. What would that be written as a mixed number? Well, how many times does 10 go into 50? 10, 20, 30, 40, 50. 5 times. 10 times 5 is 50. There's 1 left over. My denominator stays the same. Great job. Hopefully I'll see you soon. I'm still missing you, 5th graders. Bye for now.